Hello, hello, and welcome back. We are still looking at measurement and equivalent ratios. So, looking at this picture, how many circles are there for every triangle? Well, we look here, there's two, if the repeating pattern, right? There's two circles for every triangle. So, it's a 2-to-1 ratio. These are circles here, and these are, why are you not writing for me? And these are triangles. Okay, so the ratio is 2-to-1. Now, how many circles are there for every 2 triangles? So now I'm going to look every 2 triangles here. I'm going to actually use one of these. So now I'm going to look every 2 triangles. Well, that would make the ratio 4-to-2, right? And now, what if I'm looking at for every 3? And that ratio would now be 3 triangles to 6 circles, right? Well, if I kept going this pattern, right, and I added some more circles in and triangles and circles and triangles, right, I can keep going. So I'm just going to erase some of these so that I can show. So if I wanted to know what the next ratio is, right, if I had 4 triangles, that would be 8, right? So every 8, that would be a new part of the ratio. And I can keep going and going and going. These should be reminding you of something, okay? This is very similar if I had, so say I had a half, and then all of a sudden I have 2/4 and I have 3/6. Okay, these 2/4 is equivalent to a half, 3/6 is equivalent to a half. It's the same as the ratios here, okay? The 2-to-1 ratio, the 4-to-2 ratio, right? All I've done is multiplied by 2 there, okay? To get from here to here, I've multiplied by 3. To get to here, I've multiplied by 4. So these are equivalent ratios. So equivalent ratios as opposed to fractions. Okay, so if I wanted to have an equivalent ratio here, I have a 2-to-1 ratio, right? There's a 2-to-1 ratio. Okay, I'm just going to circle that. We're going to get to the equivalent part in a second. Just showing you, all right, now I can add another group. I can add another group, right? I can add another group, and I can add another group. These are still 2-to-1 ratios. Okay, if I wanted to show a 4-to-2 ratio, I could just do it that way. And then I could add more groups in again. Okay, so if I had a 1-to-4 ratio with 15 circles and triangles, what would that look like? How do I figure that out? Well, I would look at the ratio first and know that in total, I have, in one group, I'm going to have a total of 5. So I would have, if this is circles to triangles, right? So that would be one group. So I'll just keep going actually. Here we go. And that's 15 in total. All right, so the 15 is the total shape, so I just made sure I made groups that would equal that amount. So what I want you to do right now is to think about this. You have 15 in total, and I just want you to pause the video, and I want you to draw out these two, just to show that you can do it, just to make sure you understand before moving on. So please pause the video and make sure you do that. All right, welcome back. So I have 3 circles, 2 triangles, and there's 5 in total in the group, right? 3 circles, so that's 10. 3 circles, 2 triangles, that's 15. All right? Same thing again, there's 5 in total in the group, but now there's 4 circles and a triangle. And 15 in total. So, is it possible to have a ratio of circles to triangles that has a total of 15? I just want you to stop and actually think about this. Come up with a logical explanation to why you think yes or why you think no. Pause the video and give it a good thought. So, I'm hoping that you realize that if I have a 3 to 5 ratio, okay, that means 3, 4, 5, I have 8 in one group. So the next possible grouping total altogether means that I would have 16. So that would be a no. I cannot have a total of 15 there. All right, and that's going to lead us to multiplying to make equivalent ratios. So I already kind of talked about equivalent ratios, but we can also learn how to use this information in order to find out the whole. So I have a school with 300 students, so that's the total actually, and has 3 boys to every 2 girls. Okay, so we're going to do a part to whole ratio, meaning I need to know the whole, but I need to know how many to the whole. So how do we figure that out? Well, if I were going to keep going here, okay, I know that there's 5 in total, in the total group. So I need to know how many groups. So this is like making an array, right? Where I have like this. So that's boys and girls, okay? And then I would have to find out how many groups in total. So this would be, basically there's 5 columns, and I'm trying to figure out, I know the total, right? This would be just like doing arrays, and what I don't know is how many columns there are. So I can use the total and make a division statement. So just gonna make some space here. All right, so I would take this total amount of columns, right? And I would divide that into 300, which would be 60, right? So now I know how many groups there are. So it's the same as saying how many columns there are in an array. So hopefully that makes sense. All right, now from there, I can think about, like, how am I going to determine how many boys are there? So how many boys are in each group? Well, there's 3 boys in each group, right? And there's 6 groups. So I can say 3 times 60, right? It's just like taking that array and splitting it and going, what is 3 times 60? Okay, and that's 180. And then I can find out the amount of girls by either subtracting that from 300 or going 2 times 60, which is going to be 120. And if I add that together, that is going to be 300. Okay, so this is the amount of boys, and this is the amount of girls in that group. Okay. Hopefully this made sense. We are going to go over this in class, so and go over your work in class. Okay, so equivalent ratios are very similar to equivalent fractions. How do we find equivalent fractions? Well, I'm going to multiply the top and bottom by 2 there, and this is 6, and that's going to be 8. Then I can multiply the top and bottom by 3, which is now going to be equal to 9 and 12. Those are equivalent fractions. Equivalent ratios is the same concept. So a 6 to 8 ratio is very similar, right? A 9 to 12 ratio. Okay, so I just want you to find two equivalent ratios there. So you can have anything here as long as you just multiply both of them by the same, right? So if I multiply by 3, if I multiply both by 100, still equivalent. All right, here, 8, 10, right? This could be multiplied by 3. Okay, multiplied by 2. And then 3. All right, there are 3 girls for every 5 boys. So there are 3 girls for every how many students? So when I'm doing this problem, the first thing I'm going to do, obviously, is this is a 3 to 5 ratio, meaning inside one group, there's going to be 8 in total. So there's 3 girls for every 8 students. And this is girls to students. I could also ask the question, how many boys? And it would be a 4 to 8 ratio for how many students. And then I can say, you know what, if I had 16 students, then I would have, if I had 16 students, right, that's double that, multiplied by 2. Why do I keep doing that? Used to do it fractions. Okay, ratio. And that would be 8. And then if I said I had 24, right, that would be times 3. So that'd be 12 to 24. So you keep going along like that. All right, let's erase this so you can see what's happening here. So again, the ratio for girls to boys, say it's 3 to 4 now. Just figure out how many girls we have to the whole and how many boys we have to the whole in ratios. This is not hashtag, this means number. All right, pause the video. All right, so the number in total is going to be 7, so this would be a 3 to 7 ratio, and this would be a 4 to 7 ratio. And if I said the question differently and I didn't want ratio and I wanted fractions, what would the fraction of girls be in the class? It would be 3/7, and this would be, if boys, 4/7. So it depends on how the question is asked, how you're going to answer in fractions or ratios. All right, so you do have a worksheet that goes with this. We will be taking some of these questions up in class, so make sure that you have it done and you're ready with questions.